Good morning. Hope you're doing well. Find a possible solution for f of x, given that f of x equals integral sine of pi x cosine of pi x. Okay? Let's see what we can do with this. So, first thought is, when we're looking at an integral, think, well, can we use the power rule? No, we really can't with this, because the power rule is like a x to the third, x to the fourth, x to some sort of power. This is not that. Next, we usually look for is substitution. Substitution is you look for one thing that's a derivative of another. So we have cosine, which is a derivative of sine. We also have sine, which is a derivative of cosine, more or less. There's some negatives involved, but those are details that we can deal with. So what we're going to do then is we're going to say, well, we're going to rewrite it first because it helps me visualize it when I tactile, when I write it out. It gives me a better feeling for the problem. So I'm going to say u equals sine of pi x. And then the derivative will be, derivative of sine is cosine pi x dx. Then we also have to do the chain rule here because it's not just x in the middle. And so that will be pi. So pi dx. Seems pretty reasonable. All right, change colors. Ooh, red. Very bold. Very bold. All right, so then we have integral of u, and then, probably should solve for dx over here. Solve for dx, so du over pi cosine pi x equals, nope, we're going to do this differently, equals cosine of pi x dx. I could have put the cosine of pi x on the left side, and then they just would have canceled out when I wrote it out. I prefer this method. You'll see. So we have cosine pi x dx right here. And then we also have it right here. And so this is going to give us du over pi, which will be u squared over pi du. U squared over 2 pi du. Okay? And then we substitute back in. Ooh. There we go. And a plus c. Substitute back in our x value. We'll have sine squared pi x. That's the same as if the squared was on the outside. All over 2 pi plus c. And this is actually a different c than above, but since they're all just constants, I could be like, well, this is c1, this is c2. It's okay. Just a constant. Don't have to be specific. But this is just asking for a possible solution. So that's why they leave off the c here. They're like, well, maybe the c is 0. Okay. So sine squared pi x over 2 pi. Sine squared 2, aha, right here. Whoop, 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 whoop. Excellent. So now one thing you might be thinking is, wait a sec. Why did I choose u to be sine of pi x? Can I have chosen cosine? Isn't there also some sort of derivative integral relation there? There is. And, in theory, I should be able to choose cosine of pi x and still get the correct answer. Well, assuming I do the question correctly, which is a big if. So let's try that real quick. It's good to see it. So let's say u equals cosine of pi x. And du will then equal negative sine of pi x times the derivative of the interior, which is pi dx. Rearranging this a little bit, we get negative du over pi equals sine of pi x dx. Changing colors. You don't actually have to change colors. It's just something that I like to do. We get something along the lines of integral u Then sine of pi x dx, we get I'll write the negative as -1. That way it's just easier to see that it's not a subtraction. All over pi, which gives us negative u squared over 2 pi. Yep, and then plus c. And we get then cosine squared negative pi x, cosine squared pi x over 2 pi. Huzzah! Got the answer. So then we come over here and we see that that looks nothing like it. So here's where, this is why this problem is valuable to look at from two different angles. So if you remember the Pythagorean theorem, we have sine squared, I'll say, of x, could be of theta, cosine squared of x equals 1. So if we take this cosine and move it over to this side, we'd have 1 minus cosine squared of x equals sine squared of x. Well, this c is an arbitrary constant. Arbitrary meaning it can basically be anything. There are some limits to being arbitrary in life, but it means that it's not really set in stone per se. And in this case, we're going to say that this is 1. So if we rewrite this, we then have 1. Actually, I'm going to call it 2 pi over 2 pi. Can I do that? Maybe I should do that. I'll try that. So we have 2 pi over 2 pi. Maybe? I don't know. We'll go for this. Cosine squared of x all over 2 pi, which equals nope, I'm going to change this again. Whoop. I'm going to call this 1 over 2 pi. It's a constant. We can call it what we'd like. 1 over 2 pi minus cosine squared of x over 2 pi. Whoop, over here. This gives us 1 minus cosine squared? Oh, that was terrible. I am trying to salvage it and it is not working. Here we go. And based on the Pythagorean theorem up here, we get sine squared of x over 2 pi. So what I'm saying here, is there supposed to be a pi? There's supposed to be a pi involved here. Put a little pi, a little bit of pi. Usually I get angrier when pi is missing because I get my hopes up, I get hungry, and then it's lost to me. Okay, so my proposition here is that this sine squared of pi over x over 2 pi is in fact the same as, over here, negative cosine squared pi x over 2 pi plus c. So that constant, it can be chosen in such a way these are actually the same answer. So even though we got something with negative cosine squared pi x, it's actually the same answer as sine squared of pi x over 2 pi. The only difference between the two is a constant. And that constant we pick up because we integrated. So the fact that we got a different looking answer doesn't mean it's not equivalent. And that's why for this one, you can choose either sine of pi x or cosine of pi x as your substitution, and both will give you the correct answer. So the question then is, well, which one do I know to pick? Because if I chose sine, it'd be very obvious which answer was correct. But if I chose u equals cosine of pi x, then it gets kind of tedious and difficult and you're not quite sure. Very true. You just do your best. There is no good answer there. The reason I would choose sine pi x initially is because it's easier to take the derivative of sine and cosine because it just goes sine to positive cosine, where cosine goes to negative sine when you take the derivative. And that's not a really good reason, but that's why I would go down that path, because it's slightly easier. But it'd be completely legitimate to go the other way. Sometimes you get unlucky, and even though you have the right answer, the form is not quite what the problem was looking for. And the best thing you can do then is just jumble it around and try and make it fit what the answer wants. So sometimes you get unlucky in life, you work with it, you do your best, but as long as you don't make mathematical errors, you can always go back and figure it out, assuming you have time. So that's the best advice I give for this kind of problem. So not too hard to solve, but you can get unlucky and set yourself up for a difficult interpretation of your answer. So that's how I would tackle this problem. Thanks, guys. Go team. See you next time.